thanks for clicking on this video. So this video is starting off a new unit in Precalculus for polynomial functions. And today we're dealing with specifically the degree of polynomials. If you want to follow along, the links to the companion worksheet are in the description below. Also, if you want to see more videos from the channel, don't forget to click that subscribe button to stay up to date on all the videos we have coming out from the channel. So let's get started. So when we look at the degree of a polynomial, one way to do it is to look at the equation. And all the degree is going to be is the highest power on x. So when we look at a function, we look at all the powers of x. So this has a power of 0, because you could think of it as x to the 0, where anything to the 0 power is just 1. Here, the power on x is 1. Here, the power on x is 2. Here it's 3. Here it's 4. Here it's 5. So for this polynomial equation, the degree equals 5. Now looking at number 2, students often get the wrong idea that the degree is often the power on x that comes first. Now, usually it should be, because when mathematicians write a polynomial, they always write it with the highest power, and then they write them in descending order. But for number 2, it's actually not what the degree is, because 3 is not the highest power. It's actually 4. That's the highest power. So oftentimes you'll see books give you a problem like this just to see if you're paying attention, or if you're just tuned out and just writing whatever the first number is, which is often, but not always, the highest power. Now sometimes it could also be given to us in factored form. Now we could take our time and factor this thing out, but what we could do instead is say, all right, from each part, look at what x is, because that's what's going to give us the highest power on x in each binomial factor. So that's 2x times negative x times x. So when we multiply all that out, we're going to get negative 2x cubed. Now, if we were to multiply any other combination from these binomials, we would get a lower power on x. So that means for this one, the degree will equal 3. And if you want to plug this into an online computer algebra system and have it expanded out for you, you can do that. But this is a little bit quicker, because all we need for this problem is the degree. Now for number 4, we're going to do the same thing, except you have to notice that this factor is squared and this factor is to the 4th. So we still take the same approach. We have x, but that's squared. We have x, here we have 2x, and that's to the 4th. So here, x squared becomes, well, just x squared. I can bring that inside the parentheses. Here, I have 2x quantity to the 4th, so that means that 2 to the 4th is 16, and then we've got x to the 4th. And so when we multiply, the number out front is 16, and then the powers of x are going to be 2, 1, and 4. Now when we multiply, we add the powers of x. So that means that's going to be to the 7th power. So that means that is our degree. It's 7. Now in number 5 and number 6, here we have graphs. Now the way you can tell with a graph what the degree of the polynomial is, and sometimes you'll have a graph that looks like this and sometimes you won't. But what you want to look for is you want to look for the number of times the graph changes direction. So here the graph is coming down, but then it changes direction right here. I'll just call that a change in direction, COD, and then it starts to go up. Now at this point, it changes again. Got another change. And then down here, it's got another change. So in total, we have 3 changes in direction. So that means what we do is we take that number and we add 1. We always add 1. And so that means we end up with 4 as our degree. So whatever the number of changes in direction are, you add 1. And so this is a polynomial of 4th degree. And then here in number 6, same thing. Here we've got 1, 2, 3, 4 changes in direction. So that means to find the degree, we add 1. So our degree is 5. So that's how we find polynomial degrees from either graphs or equations or factored equations. Thanks for watching. If you liked the video, please give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.